All right, the hottest story of the week happened to be about hot Jupiters. And that is good news for me, because I'm such a geek, a dork, and a nerd. I enjoy hot Jupiter science. Now, what is a hot Jupiter? A hot Jupiter is a Jupiter that's really, really, really close to the star. Now, our Jupiter, far away. Hey. Yeah, hot Jupiter stories were everywhere this week. And it seems like hot Jupiter is the norm, and our Jupiter is the oddball out, the weirdo in the universe, if you will. Which brings me to beg the question, did Jupiters move in, or did they move out? Is our Jupiter slowly moving in, or is it slowly moving out? I'd like to know. Warning, this video might be boring. I'll have to throw in a lot of funny memes or something. I don't know if you know this. Thor News is for winners, and that's why you're here. So stick around. Hit the button, baby.
Party dance time.
Stay cool. This is a Thor News presentation. Thor News presents. We are over at NASA.gov, getting our freak on. March 28th, 2016, by the Spitzer telescope, investigating the mystery of migrating hot Jupiters. The last decade has seen a bonanza of exoplanet discoveries. Nearly 2,000 exoplanets, planets outside of our solar system, have been confirmed so far, and more than 5,000 candidate exoplanets have been identified. Many of these exotic worlds belong to a class known as hot Jupiters. These are gas giants like Jupiter, but much hotter, with orbits that take them feverishly close to their stars. At first, hot Jupiters were considered oddballs, since we don't have anything like them in our solar system. But as more were found, in addition to many other smaller planets that orbit very closely to their stars, our solar system started to seem like the real misfit. We thought our solar system was normal, but that's not so much the case, said astronomer Greg Laughlin of the University of California, Santa Cruz. He was the co-author of a new study from NASA's Spitzer Space Telescope that investigates hot Jupiter formation. Now, there's a real shady line between Jupiter, brown dwarf, and a star. And that's what we're trying to figure out. Like, what the hell's going on? Right? Okay. As common as hot Jupiters are known to be, they're still shrouded in mystery. How did these massive orbs form, and how did they wind up so shockingly close to their stars? Now, science likes to tell you that planets and stars formed when a giant cloud of gas and dust gets so heavy in outer space, it collapses upon itself, just creating a star and planets. But then, how does it know to differentiate rocky planets into rocky planets, gas giants into gas giants, and Earths into Earths? You know what I'm saying? Like, I don't know. Seems like there's a lot we're missing. That's what we're here searching for. Sometimes I wonder if Jupiter is the sun's binary companion. The Spitzer telescope found new clues by observing a hot Jupiter known as HD 8066b, situated 190 light years from Earth. The planet is unusual in that it has a wildly eccentric orbit, almost like that of a comet, swinging very close to its star and then back out to much greater distances over and over again every 111 days. One side of the planet is thought to become dramatically hotter than the other during its harrowing close approaches. In fact, when the planet is closest to the host star, the side facing the star quickly heats up to more than 2,000 degrees Fahrenheit. Wow, that is hot. You can melt my butter. And over in this picture here, we see the turbulent atmosphere of a hot gaseous planet. Sweet. As the planet gets closer to the star, it feels a burst of starlight, or radiation. The atmosphere becomes a cauldron of chemical reactions, and the winds ramp up far beyond hurricane force, said Laughlin, a co-author of the Spitzer study, which is accepted for publication in the Astrophysical Journal Letters. This article's kind of boring. All right, more than you. This article's kind of boring. HD 8066b is thought to be the process of migrating from a more distant orbit to a much tighter one, typical of hot Jupiters. One of the leading theories of hot Jupiter formation holds that gas giants in distant orbits become hot Jupiters when the gravitational influences from nearby stars or planets drive them into closer orbits. All right, like I don't see Mercury pushing a hot Jupiter towards the sun. I don't see like Neptune pushing a hot Jupiter towards the sun. I can only see the star pulling the hot Jupiter towards the star. You know what I'm saying? So I'm wondering, at what point does that process begin, where the sun begins to pull the hot Jupiter in for a little hot love making, stellar style? The planets start out in eccentric orbits, then over a period of hundreds of millions of years are thought to gradually settle down into tight circular orbits. This planet is thought to be caught in the act of migrating inward, said Julian DeWitt of the Massachusetts Institute of Technology, Cambridge. He's the lead author of the new study. By studying it, we are able to test theories of hot Jupiter formation. Spitzer previously studied HD 8066b in 2009 The latest observations are more detailed thanks to a longer observing time, 85 hours, and improvements in Spitzer's sensitivity to exoplanets. The Spitzer data are pristine, said DeWitt, and we were able to observe the planet for much longer this time, giving us much more insight into its coldest temperature and how fast it heats up, cools down, and rotates. A key question addressed in the study is, how long is HD 8066b taking to migrate from an eccentric to a circular orbit? One way to assess this is to look at how squishy the planet is. When HD 8066b whips closely by its star, the gravity of the star squeezes it. If the planet is squishier or more pliable, it can better dissipate the gravitational energy as heat. And the more heat that is dissipated, the faster the planet will transform into a circular orbit, a process known as circularization. If you take a Nerf ball and squeeze it a bunch of times really fast, you'll see that it heats up. What? That's because the Nerf ball is good at transferring the mechanical energy into heat. It's squishy as a result. Why is the story so boring? The Spitzer results show that HD 8066b does not dissipate much heat when it is squeezed by gravity during its close encounters, and thus is not squishy. All right, did you hear that, everybody? Science is determined the hot Jupiter's not squishy, but it's rather stiffer as a whole. All right, so gravity plays with it until it gets stiff. Strange. This suggests the planet is not circularizing its orbit as fast as expected. It may take another 10 billion years or more to complete. Oh, isn't that cute? We are starting to learn how long it may take for hot Jupiter migration to occur, said DeWitt. Our theory said it shouldn't take that long because we don't see migrating hot Jupiters very often. The long timescales we are observing here suggest that a leading migration mechanism may not be as efficient for hot Jupiter formation as once believed. A rotation rate of 90 hours is much slower than what was predicted for HD 8066b, puzzling astronomers and adding to the enduring mystique of hot Jupiters. Okay, we haven't really learned much, so that's great. And this might have been my most boring article ever, so that's great. Sweet.